Welcome to part 3 of quantitative analysis. We're going to be discussing odds ratio. This is an extension of the part 2 discussion on inferential statistics. So when we are discussing an odds ratio, when you see this reported in a study, it is basically providing information for clinical decision making by calculating the risk for various problems or the odds that a specific undesirable outcome will occur in a population. So here's some of the ways that that's reported. It can be reported as absolute risk, which is the proportion of people who experience an undesirable outcome in each group. Or it could be absolute risk reduction. If you wanted to look at the same issue with a positive slant, you would look for risk reduction. The odds ratio, which we discussed in inferential statistics, which is the odds that something will occur, and the number of people that are needed to treat to prevent the one undesirable outcome. The odds ratio is the odds that the proportion of people with an adverse outcome relative to those without it. So there's many ways that an odds ratio can be defined. And when you're reading a research study, look for this, and it's abbreviated as OR. And so they will report both the OR, and usually they'll do it along with the confidence interval that we discussed. So it's computed compared to the odds of the adverse outcome for two groups that are being compared. Like, what are the odds for this outcome if you're a man versus if you're a woman, if you're in the experimental group versus in the control group. Here's an example of a study that is using reporting their data with a confidence interval and an odds ratio. Now notice some of the key words here. It was a cross-sectional data that was used. They did a logistic regression, and it was adjusted for all these different characteristics of the sample. So when they ended up looking at this, they compared white adolescents, Hispanic adolescents, and Black adolescents. Hispanic adolescents had a higher odds, and they adjusted that based on all these different pieces. So they looked at all these different confounders, which is a very strong design. And so this group had a higher odds, the Hispanic adolescents, compared to the whites for vaccination, and Black adolescents had a lower odds of vaccination compared with white. So these are adjusted odds ratio, and that's abbreviated AOR. So that means if you look at this, if you look at 1.11 as the adjusted odds ratio, that means 11 out of 100 Hispanic like if you took groups, 100 Hispanics, 100 Blacks, and 100 whites, 11 more of the Hispanics would be vaccinated compared, like, to, if you got 100 whites vaccinated, there would be 111 Hispanics for every 100 whites, and then there'd be 95 Black adolescents vaccinated for every 100 whites vaccinated, is one way that you could look at it. Now, if we had it instead reported with the Hispanic group being the center, then instead you would see an adjusted odds ratio for the white population would be around 90 or 0.90. And then the Blacks would be, if you took 100 and subtracted 116, would be about 84. So it would be 89, 84, and 100. So the adjusted odds ratio and how that is reported, it helps you to understand the interpretation of the data. Here's another study that's reported, and then they use this term adjusted model, pre versus post. So know that sometimes when people will say adjusted, what they're talking about is adjusted odds ratio. And they had their two groups were the pre-group and the post-group. And so that's how these statistics are reported once again, adjusted for co-founders with analysis of covariance. And we talked about that in the second slide set as being looking at the various means between two or more groups. And in this case, the groups were the pre and post-intervention group. So I show you this because I want you to begin understanding when you see these terms, just being able to categorically place this language into a box. Like, is this a relationship that could be considered predictive? And then again, looking at the p-value here, this p-value is extremely small. For every 1,000 people, this difference would only happen by chance with 5 of them. So we see, wow, this is a very significant difference. And then we ask ourselves, is this clinically significant? And that it's harder, more difficult to tell about the clinical significance of it. But for those 10% people, or 15% of folks, perhaps that did make a difference, but more testing would be needed to understand how important that is. It would be much more significant if the post-intervention group could achieve 100, then we would know that they were totally getting the entire education that was offered. So these are just the kinds of questions and things to think about when reading a research study. What I want you to understand is that the odds ratio determining risk is a powerful statistical analysis. Terms associated with point-based inferential statistics includes the odds ratio itself, because that's one number, and then associated with interval are the confidence interval or the range of those results. So thank you for watching.